Okay, this chapter is about sampling, which is going to become critical for you as you're trying to figure out how to conduct your research uh, experiment or your dissertation and process later on in the program. So, the most famous sampling mistake, I think you'll probably recognize if you remember from your history class, is this, and I think everybody knows who that is. It's Harry Truman. And he was predicted to lose to Dewey. And it was really confusing as to how this went so badly. And here's what happened. When they conducted the survey, when the Chicago Daily Tribune conducted the survey, they only asked rich white people with telephones. That's who their sample was. So therefore, there's an entire part of this country that was not included in that, and therefore they had a poor sample. So what exactly is a sample? A sample is a subset of the population. And in theory, your sample should look like your population. And there's two ways in which we can do that. There's two general methods. There is a probability sample or there's a non-probability sample. Just because it's a probability sample, that does not necessarily mean it's random. There's some different degrees of that. You simply know the likelihood of any member of the population being included. And we would like to increase the likelihood of that happening as much as we possibly can. So probability or samples can be divided into two categories. As I said, there is probability samples and there's non-probability samples. And then there's subcategories within that. There's simple random, systematic random, stratified, multi-stage clusters. And then for non-probability samples, there is convenience, snowball, quota, and theoretical samples. So for a simple random sample, basically you have to get a list or a sampling frame from which to pick. And this is the hard part, because when you do that, you cannot systematically exclude anyone. And for example, going back to the issue with Dewey and Truman, is they did not have a good sampling frame. They automatically cut out a lot of people. You then have to determine the sample size. So how big does your sample have to be? Well, there's actually a calculator that you can use, but this table is still pretty handy. What this shows you is the relationship between the sample size and a population. So for example, if you have a school district that has 1,000 teachers in it, you actually only need to sample 278 of those people, as long as they actually look like the population. And this takes some work to be able to do this. If you have a population, let's say of a city of 100,000 people, your sample only needs to have 384 people. But being able to select what your original sampling frame is really the hardest part and the most important part of that. So then you need to generate random numbers. And there's a chapter, or there's a page in your book, I think it's table 6.1, that has a table of random numbers. That's a very redacted random number generator. You list all the members of the population, and then you select one person per random number. So on that table that it has, if you look at that, if you need 372, you randomly pick one of those columns. You figure out how many digits. So if you need 372, you have to go 3 digits over. And you start with the first one. So for example, if I needed 372 people, and I look at table 6.1, and I randomly selected column 4 in my first row, I need 3 digits worth of this. So I select the 298th person. Go to row 2, the 224th person. Row 3 is 552. I don't need 552 of these. Next, 366, I don't need that. So you keep having to work your way down until you get the number of people that you need. Again, this this table is very much reduced in its size. And actually, there's an online way to do this now that it will randomly generate those numbers for you. And then you select one person for each of those numbers. So what's the advantage to this? It's easy to conduct. There's a high probability of achieving a representative sample, and it meets some assumptions of statistical procedures that as we move on into how we're going to run a test and compare and test our hypothesis, that this will take care of. The downside of that is it's very difficult to identify all the members of a population, and it's very difficult to contact all the members of a sample. So for example, if we're going to go back to the population of a city, say the size of Wichita Falls, if you're going to use simple random sampling, that means you've got to identify all the people who it is that you want to talk about. If you want to talk about the voters in Wichita Falls, if you're talking about a bond election, then you actually have you need to have a list of who those people are. But you also need to be able to have a way to contact all of them. Otherwise, you're systematically eliminating somebody from that population. The next type is something called systematic random sample. And this is basically you select a random number, which we know as K. You get a list of people or reserve a flow of people, and you're going to select every kth person. So you randomly think of number 17. Now I've got this list of people in my population of 100,000 people, and I want to select every 17th person. So you want to make sure that there's no systematic rhythm to the flow or the list of people, because the way that the list shows up may influence how you select people. If you get a list of voters and those voters are listed by voting precincts, well, now you're going to run the risk, depending on what your kth number is, you're going to run the risk of selecting just people from wealthy neighborhoods or just people from poor neighborhoods. So, because if every fourth person on the list is rich or a senior or some other consistent pattern, that's going to create an issue with that. This is pretty easy to do. That's the advantage of it. The downside of it is some members do not have an equal chance of being selected, because once a person's selected, that person is no longer part of the sample population. So now you've reduced the number of people about whom you can access. Stratified random sample. This is where and this is more common in education research. It's where you separate your population into groups or strata. So you take in consideration grade level, age, income, and you consider the population and the sample size. So let's think about a school population, high school population, and you want to know some information about what high school students think. Well, you want to make sure that you have representatives from each grade level. You don't want to put yourself in a position where potentially, if you did it alphabetically, it's possible you could select only sophomores in your sample. So you make a strata that includes grade level. You include a strata that includes gender and strata that includes ethnicity, because you really want your sample to look like your population. So once you get to that point, you either then do a simple random sample or a systematic random sample from there. You must know easily what the strata are before attempting this. And if your sampling frame is sorted by, say, a school district, then you are able to use that method. So the advantages of that is you can get a more accurate sample, and what I mean by that is you're increasing the odds that your sample really looks like your population. It can be used for something called proportional and non-proportional samples. And what we mean by that is if we have a non-proportional sample, that means we may not have as many freshmen as we do seniors. But this way is a way of guarantee that you have a representative sample of that. And you get a lot of subgroups represented in your sample. The disadvantages of this is the identification of all the members of the population can be really difficult. depending on how complex your population is. Um, and therefore, the members of the subgroups can be very difficult to identify. Uh, that being said, the advantage to me for a stratified random sample, really outweighs the cost of it, because you're ensuring or trying to ensure that on a very complex issue that these variables may influence how people perceive an issue. This is really one of the few ways by which you can figure out, does our sample look like our population, so that when we do something to this sample, we can reduce the likelihood of making a type 1 or a type 2 error. A multi-stage cluster is a more complex version of a stratified random sample. So these are done with clusters or branches of company, grade levels, etc. And then you take random sample clusters from that list. So what you do is you estimate the average number of population members per cluster, and you determine the number of clusters needed by dividing by the sample size, by the estimated size of a cluster. And you randomly select people within those branches of the schools. This is extremely complex and time-consuming. It's useful when the populations are large and spread out over a large area, for example, the size of a school district. It's expedient in terms of trying to, once you actually have all this listed out, of trying to actually do something with those people. And you don't need the names of everyone in the population. So if you think about a school district and how it's constructed in a very large school district, you can pick clusters from that and then select clusters within that. So as long as your clusters look like the district itself, then the generalizability of that is going to be much easier to implement. That being said, there's always going to be a question about, does our sample really look like our population? So as complex as that is, I still think that one of the advantages is doing this, especially with what you're going to do. You're probably going to use something like this to be able to implement a solution, or there's some other things that may come up which are non-probability samples, and we'll talk about those next.